Hello, welcome to the demo video of our project for CSC 591, Perception in Robotics. The title of our project is Smart Body Measurement. Shopping for apparels at stores can often prove to be tedious as it is important to test the garment size and fit by actually trying them out. The main goal is to create a virtual fitting room interface where the user can visualize the quality of fit in different sections of his body. To complete the project, our team shared the workload as shown in this table. Obtaining the body measurements directly from the Kinect sensor proved to be the most challenging task. In the project, we've used the Kinect sensor as our input source as it has both an RGB camera and a depth camera which uses infrared technology. Kinect can easily identify human bodies present in its frame. We were able to extract the skeletal data of the body using the library. We have developed our backend application of the .NET framework which runs on a Windows machine. The user interface was developed on Unity, which displays the measurements, the color-coded body model, and an option to change the size and fit. The UI runs on a Linux machine. A 3D mannequin model is also displayed in the UI to better understand the fit in 3 dimensions. To render the 3D model, we used a software, MakeHuman 3D, and Blender to export OBJ and texture files to be used in Unity. We used ROS to maintain two-way communication between the UI application running on the Linux machine and a backend application running on the Windows machine. The two applications send and receive relevant messages by publishing and subscribing to the desired topics. To showcase the technology, we chose to take 4 measurements required for a shirt: chest, waist, bottom, and sleeve size. We assumed these parts to be ellipses whose perimeters would be approximately equal to the real body sizes. Hence, to get the corresponding major and minor axis lengths, we first acquire the front and side view of the body and then perform computer vision tasks like background removal, edge detection, and coordinate mapping. The idea here is to use various joints coordinates obtained from the skeletal data and find useful reference points to mark the locations required for all the computation in the process. The Kinect SDK uses color and depth sensor data to offer 3 different coordinate systems: camera space, depth space, and color space. The joint locations are read in the camera space, which are the real-world coordinate points in the camera's frame of reference. We map these coordinates from camera space to depth and color spaces, perform the viral computations, and then reverse map to calculate real lengths of the minor and major axis in centimeters. The computed measurement data and an RGB image of the user are then published onto the respective ROS topics through a ROSBridge client. The Unity-based user interface then displays them by subscribing to these messages using the WebSocket activated on ROS. The user has an option of selecting the size and fit he or she wants to test on the garment, which are sent back to the backend application to request the color-coded image that are to be displayed next. This project can further be realized as an important part of an ecosystem to make the entire shopping experience hassle-free. Once the user visits any clothing center, the measurement data can be stored with his profile. This would then enable the user to shop through the store's online portal at his convenience. We finally want to thank Professor Yang and Varun for their constant guidance and support.